We're talking about piecewise functions. Here's a really good example, a very common one that people don't realize is happening in their lives, but it is. So suppose I graph the amount of tax that you pay each year on your yearly income. So all the different incomes are plotted down here, from people who make a few $1,000s to $50,000 up to $100,000. It's put in scientific notation here as E1 E plus 5, it's just $100,000. And we're supposing that the tax people pay on that is that people pay zero tax here, then it goes up moderately, and then it has this break point where it goes up steeper after that. This is typically, as simplified, but this is a typical kind of tax structure where as your income goes up, not only do you pay more tax, but the rate at which your taxes increase is going up as well. And so there's a lot of cool stuff to say about that. Hopefully we'll be able to say that in a few days. But the main thing we want to do is just, how would you write down a description of this? How would you write down a formula for this? Okay. And so we want a formula for a function f so that the tax you pay is that function applied to your income. Okay. So what have we got here? Let's just look at the structure. Let's hide that so it's not distracting. Let's look at the structure of how we write this kind of thing. We want to have, there's three different formulas here that are active. There's a formula that's going to go on here. That's a straight line formula. There's a formula that's going to work here. That's a straight line formula. And there's a formula that's going to work here. That's another different straight line. And what I want to focus on is just exactly how that gets written down. Sorry, keeps getting the other example in there. There we go. Okay, so okay, that should work better. So we've got three possible formulas here, and here's how that gets written. That the function f, this is one function with three pieces. It's going to be called a piecewise defined function. When I apply that to I have to do an either or. And so let me write it out what it looks like, and I'm going to explain the notation. So it's going to be 0 if 0 is less than or equal to I is less than or equal to 10,000. It turns out to be 0.1x minus 1,000. That's a straight line. We know that mx plus b, it's just in exactly the slope-intercept form. That's if 10,000 is less than I is less than or equal to 50,000. That's the second piece. And it's going to be 0.2x minus 6,000 if 50,000 less than I less than or equal to 100,000. Okay. And so the way you want to read this is, if you maybe say a few more words, you can say it's kind of a little paragraph or some bullet points, I guess. It says if the input, here the income, is between 0 and 10,000, then use the first formula. T just gives you 0. If the input is between 10,000 and 50,000, 50,000, there we go. Then use the second formula. And if the input is between 50,000 and 100,000, then use the third formula. That's a lot to write, and this tabular form is definitely more efficient. And in fact, people often just don't even write the if, but it's implied there. And so it's understood that when you write this formula, formula and then like inequalities, that it means you use this formula when this condition is satisfied. Use this formula when this condition is satisfied, and this formula when this condition is satisfied. So one important thing here is that notice we're only using small pieces of these three different formulas. Each of these formulas, f equals 0 or the 0.1x or the 0.2x, those, if I didn't restrict them, if I didn't restrict their individual domains, those would be entire straight lines that went all the way left, all the way right. But I'm only using these pieces. And one way to think about looking at a piecewise function, using it or graphing it, we'll graph one from scratch in a minute, is that you have three different people working on the same piece of paper, and one person is only allowed to put marks in the section between 0 and 10,000. The second person's only allowed to put marks between 10 and 50, and the third person's only allowed to use this part. And it doesn't matter what these formulas give you anywhere else but in these prescribed regions. So let's look at that for something where where we give a description, and then we'll write the formula, and then we'll produce the graph. So a little bit backwards from what we did here. So here the concentration, we'll say that's C as the output variable, of a drug in a patient's body as a function of time is given by this function. Let's say the function is called G. That's a function of times T. And for the first part of the domain we're looking at, between 0 and 2 hours, it's just a nice linear increasing function. G of t is 5t. Then it becomes 20 over t. That's going to be a little more interesting for t between 2 and 24 hours. So let's see how to write that. We just are putting these formulas and the conditions together in one tableau. So I have that ready for us. So we don't really need three though. Okay, so there's two regions, and so what I'm going to do is I'm going to put the regions here. Oh, and it's not going to kill us if these overlap, but let's say it's pretty usual to have, like when you have the breakpoints, to only use, have one formula being active in case they might give different answers. So let's say that's a strictly less than. Okay. So the formula here, that's where we put the 5t, and this is where we put the 20 over t. So remember this says, if you kind of read it from the right to left, really. If you give me a number between 0 and 2, then I'm going to use the formula 5t. If you give me a number between 2 and 24, I'm going to use the formula 20 over t. So how would we graph that? Well, so again, I like to use this idea that you're working on as a paired project. One person only looks at inputs between t and 2 and uses the first formula. Okay, that's a straight line. Oh, hey, well, I've got 2 points I obviously want to plot, t equals 0 and t equals 2. And so I'm going to use 0, 0, and then 2, 10. Oops. Great. Okay. And then straight line in between. Second one is a little bit less familiar. It's not a straight line because of this 20 over t, and we'll get more practice through the rest of the semester graphing these kinds of things. But the second person, let's say they could just plot some points. Let's say if t equals 2, it's t. You're going to get t 2 and 20 over 2 is 10, so that's 210 again. Okay, so that's nice. They match up. They don't have to, and we'll look at that, but here they happen to match up. And then let's say a few other ones that are easy to do, 4, 5. Let's say 8, 2.5, and 10, 2. I'm just trying to pick easy points. We could totally use a calculator for this as well. And then 20, 1. Okay. And so that's it turns out to be a nice sort of curving curve, if you will,
going down. And so let's see what the result is. Turns out to look like this. I can make that a little smaller. Just make it smaller this way. Okay. And so let's compare that with the piecewise formula. Between 0 and 2, we're going from 0 to 10 in output, and then it changes its mind. It does something rather different, and we're doing this downward curve where we're getting these points 2, 10, 4, 5, etc.